Hi, my name is Sue. In this lesson, we will look at linear equations in two variables, their graphs, slopes of lines, and average rates of change. Linear equations in two variables. An equation that can be written in the form ax plus by equals c, where a and b are not both 0, is a linear equation in two variables. This form is called standard form. Graph an equation using intercepts. Example 1. Find the x and y intercepts of x minus 7y equals 7, and then graph the equation. So to find an x-intercept, we want to land on the x-axis, so we let y equal 0. So letting y equal 0, this whole term drops out, and we get x is 7. To find the y-intercept, then we want to land on the y-axis so we don't go right and left, so we let x be 0, giving us negative 7y equals 7, or y is negative 1. So looking at our graph, this point is the x-intercept 7, and this point is the y-intercept at negative 1. So connecting these 2 points gives us our line. Example 2. Find the slope of the line that passes through the points 1, 2 and negative 3, 5. So graphing them, we have the point 1, 2 and the point negative 3, negative 5. Slope is defined as the rise over the run. So if I would like to see how far I rose or traveled in the vertical direction, then I can count them by looking at the graph. 1, 2, 3, 4, 5, 6, 7. Or we want to be able to transfer this information so that we can do this algebraically. So let's get this ordered pair, which was negative 3, negative 5, and this ordered pair, which is 1, 2. If we take a look at this ordered pair, it has the same x value as this one, and it has the same y value as this one. So when we want to find a vertical distance, then we subtract the y values. And if we're looking for a horizontal distance, again, I can count them manually since I have the graph 1, 2, 3, 4, or I can subtract the x values since I'm traveling in a horizontal direction. So 1 minus a negative 3 is 4. And if you look at this line, it does increase as you read it left to right. So my slope should be positive. We use the letter m to represent slope. So my rise was 7 and my run was 4. Looking back at the graph and the slope between our 2 points, we want to generalize our process to form a formula for finding the slope. Since the slope was originally defined to be the rise over the run, then we found the rise by moving in the vertical direction. So again, we subtracted 2 minus a negative 5. That's how far we traveled in the vertical direction. And then, to get 4, we wanted to see how far we traveled in the horizontal direction, or 1 minus a negative 3. So this would also give us the same slope of 7/4. This process leads us to the slope formula. If x1 and x2 are not equal to one another, then the slope m of the line through the distinct points x1, y1 and x2, y2 is defined to be m is the rise over the run. And to find the rise, we subtracted the y values to get the vertical distance. To find the run, we subtracted the x values. You need to make sure that you subtract them in the same order. We have 2 special types of lines that we need to make sure we carefully think about their equations and their slope: vertical and horizontal lines. A vertical line, my blue line is vertical, has an equation of the form x equals a, where a is a real number. In my case, all the points on this blue line have an x value of negative 2. So it has the equation x equals negative 2. And its slope is undefined. Meaning, if we took any 2 points on this line and we tried to find the rise over the run, well, in this case I have a rise of 2, but any 2 points that I would pick, my run would be 0, and I would be dividing by 0, and that's why the slope is undefined for a vertical line. Now, horizontal line, like the green line, has an equation of the form y equals b, where b is a real number. So in this particular case, all the y values on this green line are 3. So the equation is y equals 3. It has a slope of 0. And we can see that by taking any 2 points on the line and looking at the rise over the run. So in this case, I didn't rise any, so I have 0 on the top, but I ran 2. So 0 on the top of my fraction is okay. I get 0. So my slope, then, of a horizontal line is 0. Next, we'll look at graphing a line given the slope and 1 point on the line. Example 3 asks us to graph the line that has a slope of 4 over 3 and passes through the point 2, 2. We would start by graphing the point 2, 2. From there, we need to rise 4 and then run to the right 3. This would give us a second point on our line. So connecting these 2 points gives us the line that we're looking for. Also, since our slope is positive, we can look back and make sure that our graph is rising as we read it from the left to the right. One important relationship between 2 lines is that they could be parallel. 2 lines are parallel if they have the same slope. The slope m1 of line L1 is identical to the slope m2 of line L2, or m1 equals m2. Also, they never intersect if they're parallel. If 2 lines are not parallel, then they will cross one time. If they cross at right angles, then we call them perpendicular. 2 lines are perpendicular if the product of their slopes is -1. The slope of line L1 is m1, and the slope of line L2 is m2, as before. But instead of them being equal when they're parallel, in this case, if you multiply the 2 slopes, their product is -1. So if that's the case, then the 2 lines are perpendicular. So looking back at our previous example, the blue line and the red line are perpendicular. Any horizontal line would be parallel to the green line, and any vertical line would be parallel to the blue line. The last example we'll look at is interpreting slopes as an average rate of change. Example 4. The graph in the figure approximates the average number of hours a person spent on the internet per week in 2004 through 2008 for each person in the United States during those years. We are asked to find the average rate of change in number of hours per week. So we need to start by changing the information we have into ordered pairs. The first year, 2004, there was an average of 5 hours per week of internet use. So we can write that as the ordered pair 2004, 5. The last bar on our graph tells us that in 2008, the average number of hours per week of internet use was 11. So this would be the ordered pair 2008, 11. To find an average rate of change in internet usage, we'll find the slope between these 2 points. So the first thing we need to do is find the change in the y values and divide it by the change in the x values. So we have 11 minus 5, and this is going to be in hours. And then we have 2008 minus 2004. This will be in years, just so you can see that when we're done, our unit will be a rate. So 11 minus 5 is 6 hours. 2008 minus 2004 is 4 years. And when we want to look at an average rate of change, an application of a slope, then we want to turn this into a decimal. So 6 divided by 4 is 1.5. So I can say that the slope then is 1.5 hours per year. Or there was an increase, because this value is positive, so there was an increase of 1.5 hours per week on average each year between 2004 and 2008. In this lesson, we looked at linear equations in two variables, their graphs, slopes of lines, and average rates of change. Now it's time to go into the homework section and work some problems on your own.